In this video, I'm going to show you logic gates. I'm going to begin with AND gate. The symbol of AND gate is this half moon shape. Usually it has two inputs, but it can have more than two inputs as well. And it has only one input, so it has multiple inputs and only one output. Let us assign the two inputs as A and B and the output as C. The mathematical way of writing this is C equal to A period B. Period means dot. It's how we represent AND gate. C is equal to A dot B. C is equal to A and B. This is how we represent AND gate. Well, if we look at the truth table of this, it's going to be like this: A, B, then C. Well, since there are two inputs and the inputs can be either like 0 or 1, 0 or 1, so there will be four four input combinations: 0 0, 0 1. So it's going to be like this: 0 0, 0 1, 1 0, and 1 1. And this AND gate, what it does is it's A and B. Like if both of them are high, high means 1, low means 0. So if both of them are high, means A is 1 and B is 1, that's only in this case, then the output would be 1. This is the property of the AND gate. So in all other cases, one of the input combinations is 0, so the output evidently will be 0. So this is the truth table of our AND gate. I'm not going to discuss Carnot map here. It's going to be maybe for another video. Let's stick to the basics here. So if we observe carefully, it can have even three inputs, like this. I'm sorry, yeah, like this. So A, B, C inputs and O is the output. So it has three inputs and one output. Well, usually the microchips which is available in our laboratories, they have two inputs and one output. So how to represent this circuit in our labs? Well, it's a combination of two AND gates. Please pardon my drawing. This is output 1, this is output 2. So this is A, B and C. So the three inputs are like this: A, B, C, A, B, C. What's actually happening is A and B are being fed to one of the gates. O1 is the output, and this O1 is fed to another AND gate having C as the input as well. So in this way we can combine two input AND gates to obtain a 3 input AND gate. This is more or less what you need to know for AND gates. Let's move on to OR gate. Now the symbol of OR gate is somewhat like this. Yeah, it's a bit artistic style, but yeah. Okay, it also has two inputs and one output. So it also has two inputs. It's the input and the output format is same as the AND gate, and the mathematical way of writing this, okay, let's suppose the inputs are A, B, and the output is O. So O equal to A plus B. This plus means it's OR. That's OR gate. This plus means it's OR gate. Okay, and the property of OR gate which differentiates itself from AND gate is like, if any of the input combinations are 1, then the output becomes 1, else the output is 0. So similarly, the truth table will be A, B and O. A will be 0, the input combinations will be 0 0, 0 1, 1 0 and 1 1. Only if both the inputs are 0, only then the output will be 0, else in all other cases it will be 1. Well, what is the 0 and 1 in electronics engineering? Well, this 0 means high and 1 means low. Usually the 5 volt is taken as positive, that's 1, and 0 volt is taken as 0, the low, high and low. Okay, this is AND gate and OR gate. Next, let's look into NOT gate. NOT gate is also known as inverter. The symbol of NOT gate is somewhat like this. It only has one input and one output. It cannot have more than one input. What is the purpose of NOT gate? It inverts. Like, if the input is 0, the output is 1. The output becomes 1. If the input is 1, the output becomes 0. So if A is the input and O is the output, then if A is 0, O will be 1, and if A is 1, O will be 0. The truth table would be A, O. So A is 0, O is 1. If A is 1, O is 0. Very simple. The NOT gate is actually very important and possible. And you will observe later, this NOT gate is used to create another type of gate. Okay, in the earlier examples, the AND gate and the OR gate, they are basically the they are binary operators, because it works on 2 or more inputs, but this is only works on one input, so it's unary operator. Well, these 3 gates, the AND, OR, NOT gate, they are basic gates. Next we are going to discuss 2 more gates, that's NAND gate and NOR gate. Well, NAND, that's written something like NAND. It means not and, that's why NAND. And NOR, it means not or, that's NOR. As you can understand intuitively, not and means is an AND gate followed by an inverter. That NOT gate, AND gate followed by an inverter becomes NAND gate. Okay, and similarly for NOR gate followed by an inverter becomes NOR gate. If you try to derive the truth table, it's pretty obvious. Like, I'm going to help you. Okay, for the AND gate, if A, B are inputs and O is the output, if it's 0 0, 0 1, 1 0 and 1 1, the output is 0 0 0 1. After this there is an inverter, so the outputs get inverted. As you can see here, output, then there's an inverter, so the outputs now become, this output here becomes 1 1 1 0. This is a truth table of our NAND gate. Similarly, you can derive the truth table for NOR gate. A, B and C are our inputs and output. A, B is the input and C is the output. Then 0 0 0 1 1 0 1 1. It's for the normal OR gate 0 1 1 1, and an inverter after this makes it 1 0 0 0. So this is our truth table for NOR gate. Well, this NOR gate and NAND gate, these are known as universal gates. Why is this such? Well, this is such because with the help of NOR gate and NAND gate, we can construct any other gate. The basic gates can be constructed with these universal gates. That's why it's known as NAND and NOR. That's why it's known as universal gate. Sorry. Okay, this is enough for this video. It's a basic introduction. Let's see if my friends need something more, then I shall make another video on this. Till then, bye bye, take care, and do hit the like button. Thank you.